Yeah, can you see my recording, Kaushal? And can you see the slides?
Yes, ma'am. Recording has started.
Okay, sure, thank you. Okay, so good morning, everybody. We are in our 27th lecture. We are talking about pointers, and we'll continue to talk about pointers in today's class. So as we have seen, I'll repeat this because I feel that this is important, that whenever we have a variable, let's say count, this we have seen in the earlier class, we are naming a memory cell called count, and throughout the program, whenever we talk about this variable count, the same memory cell gets accessed, and its address we are going to call its L value. This L and R value is with reference to the assignment operator on the side of which this appears. The L value is used on the left hand side, the R value is used on the right hand side. And we have seen that the value of count, or its the whatever are the contents, the value of that variable may change, that its R value may change. In contrast, when we have a count PTR variable, of course, we have a memory, which is memory cell, which is called as count PTR. And throughout the program, the same memory cell gets accessed when we access the L value. However, using this, using the R value, we are able to access different memory cells, which themselves are L values of some other variables. That is something that we have seen, and this is what allows pointers to have this effectiveness of being able to modify the contents of some other memory cell. So this is something that we have seen in the last class. We will emphasize that, and we will exercise it using different examples in today's class. Okay, so the example that we were looking at was the following. That is, we have these three names that we want to store, and these three names have different sizes, and therefore we said that uh, this data type, which is a two-dimensional matrix which has three rows and appropriate number of columns. The columns is decided by the length of the largest string here, which is Narsimhan, is something which can be done, which is correct. However, it is not the most appropriate thing to do because it is wastage of memory. So what we said is we can define a character array of size 3, which is which is a character array of size 3. Each of its element is a pointer. Sorry, I should not say character array of size 3. It is a array of size 3, which is each element of it is a pointer to a character. And this is the program that we were discussing. So okay, so I just want to understand, am I audible, Kaushal?
Yes, ma'am.
Okay, so there are some people who are asking, am I, okay, fine. So then the problem is local to the student. So please check your side of the device. Okay, so this is the program that we were looking at, where we have this names, which is an array of size 3. Each of the elements is a pointer to a character. And in this same place where we are declaring this array, we are also initializing the array, just the way we could have initialized some string. We have initialized the 3 elements of the array, and this is something that we have seen even in the visualizing environment. And I want to show you one of the things which is something which is important here. So this is initializing the 3 strings with the appropriate names. Of course, you remember that there is a /0 at the end of it. And in the last class, I had by mistake said that this should have been %s. This should have been %s if I remove this star from here. So what I want you to say is, what is the output of this program, which is a correct program. What is the output of this program? Assuming this is %c, the way the program is written, not by replacing it with %s and removing the star. So what is the output of this program? What does it print out? Any answers? Please write them in the chat. Okay, one of you has answered. Okay, good. So it prints out the first letters of the names, which I hope is clear. So names of I is what is going to get accessed, and then we are going to look at the first character of each of these names. So when you are at I is equal to 0, you are looking at this string SAI Sai, and the first character of this string is S, and therefore this S is going to get printed. Of course, after that there is a /n, therefore you are going to print it on a new line. So you are going to print S, L, N, L on different lines of by this program. So this is correct. I had mistakenly said that this should have been %C, %S in the last class. If you want to print out the whole names, you should of course say %S/n and then remove this star and just say names of I, because then it is a pointer to a character array, and then it will print out as long as you do not see a /0. So if I remove this star from here and write it as a %S, then you will have Sai, Narsimhan and Vishnu printed, Lakshmi printed out on 3 different lines. Okay, so any questions or comments here? Okay, so what I want to do is I want to go to the environment where I can show you this to illustrate one of the points. So Kaushal, you can see my browser, right?
Yes, ma'am.
Okay, so I'm going to take this program and anyway, I'm going to change it to %S names of I. That is okay. That is not what I want to illustrate, but let me just copy this program and write it into the visualizer. Yeah. Okay, so as we have seen, this statement, that is char star names of 3, is going to allocate an array of size 3, each of whose entries are a pointer to a character. And as soon as this line executes, that is okay. I'm sorry, should not have. Yeah, this touch screen is something that I still am not quite comfortable. Okay, so let me just run this statement, and this is the statement which is line 3, which is going to initialize it. As you see, these 3 pointers are pointing to appropriate character arrays which have been initialized with the strings that you have given and with the /0. But you should also see that the allocation is done on the heap, which was not something that we have seen till now. It was always happening on this stack, which was this execution stack, and this is the thing that is allocated on the heap. Furthermore, these are constant strings. So if you do something like I mean, at the end of this program, note that this is kind of a 2-dimensional array that you have an access to. So you can say names of let's say names of 2, 3, and you can print out. So for example, if you go to names of 2, you're going to go to this, and then 3 is 0, 1, 2, 3, which will print out H. So you can printf %C names of 2, 3, and it will print out H in this case, which is fine. But let's say you want to change this H by an S. If you try to do something like names of 2, 3 is equal to something, then it won't allow you. It will in fact it will give you a core dump on your machine or repel.it. But here I don't know what it does. If you try to do that, it may give a compile time error, or it may do some error. It will give some error. But what I want to bring out is these are constant strings. So while you can access elements of this, you will not be able to change the elements of this string individually. That is, you cannot change the characters, or you cannot change this. Of course, these pointers are something that you can change. At a later point in the program, you can say names of 0 is pointing to something else, and this array or the pointer to this is gone from you unless you have stored it at some other place. So this is something that I want to bring out, and of course after you do this, it will print out the correct things. So let me just show you that names of, if I do something like names of 2 to 3 is equal to, let's say, A, then it won't allow me to do that. Hopefully, I don't know how this visualization environment works. Okay. Okay, so it is printing it out. You can see there, I have not put a slash n, so all of them are going to get printed out. And then when I try to do this, it is going to say that it is some kind of a core dump that it is showing here when I'm trying to do this. So this is because you are trying to modify a constant string. So while you cannot modify these strings, you can modify these pointers, which are certainly some things that they are not constant pointers. So they are some things that you can modify. So are there any questions or comments here?
Ma'am, why is it core dump, ma'am? Core dump is only if you access the positions that are outside the program's purview, right?
No, it's not like that. I mean, core dump can come at other places also. You can get core dump. So you are doing something which is invalid in your invalid access that you are doing. So in some sense, this is a constant string that is given to you. You are trying to modify that constant string. So it's an invalid access that you are doing. So that is why it is showing the core dump.
Okay, ma'am. So any invalid access will result in core dump.
Yes, I mean, that is not the only place where you will get core dump, but invalid accesses you will get core dump. Again, as I repeat, it is only when you are lucky you will get a core dump, because if you happen to be, if you happen to be unlucky, that memory location is in your, it's an invalid access, it's still in your program's scope, and therefore you are making that access, and at some other place your program is going to misbehave, like array out of bounds and so on. Yeah.
Okay.
Yes. Okay. So there is another question. What is the difference between the heap and the stack, right? So this stack is this execution stack, which we are having, on which our functions, your function, the functions execution stacks are, the stack is used for this, all the local variables. Whatever are the variables whatever are the variables that are going to get allocated by something that we will see soon, which is malloc, are going to be allocated on a different memory space, which is called as heap, which is this memory space. Again, it is some kind of a different area. So all the local variables that are there, which we have seen till now, they will be allocated on the stack. And as we have seen, their scope, as soon as they go out of scope, they are not accessible to us. On the other hand, this memory is accessible as long as you have a pointer to it. So as long as you have a pointer to it, you are going to be able to access that memory. There is a subtle difference. There is a global thing that we have seen, which is on an area which is called as a global area, which I think it shows on the stack itself. So here on the visualization, it shows that it is on the stack, but it is a global area where it is stored. So that is a different space that is given, because its lifetime is different from the local variables. Okay, so Rishabh is asking, why can't we change their values? It is not about it being allocated on the heap. I repeat, it's not that memory that is allocated on the heap is not going to be, you cannot change it. It is just that it is a constant string that you have allocated here. Therefore, you cannot change it. In fact, we will see that memory that we are allocating on the heap, we will be able to change it. So please do not misunderstand by this example that memory allocated on the heap cannot be modified. Not at all. Does it answer your question, Rishabh? Yeah. Okay. So it is.
Excuse me,
again, this example should not mislead people to think that memory allocated on the heap cannot be modified or something. It's not at all the case. We will use that and we will repeatedly modify that memory. Yeah.
Names of I contains 3 pointers, right? So in the printf statement, why aren't we using the asterisk symbol, ma'am? Like how the names of I alone gives the whole string.
Okay, so I just want to show this thing as a different. Okay, so let me just use this here. So let's say that if I had char ARR of 10, right? there is no pointer. This is a character array, and let's say it has been initialized appropriately by scanf. I'm not going to write this, but let's say it has been initialized. How will I print out? And it is a null terminated string. Then how will you print out the character array?
I'll be using ARR of I, printf percentage C
ARR
ARR.
of I.
Yes.
No, ARR of I is going to print out only characters. ARR of I is only the individual characters. How are you going to print out the string? So, okay, let me just do this as follows, right? So this is equal to, let's say, CS1100. So this means that you have initialized this using the string CS1100, which is /0 terminated, right?
Yes,
Okay, now how are you going to print this CS1100 string?
Percentage is comma ARR, the name of the array.
Exactly. But remember that name of the array is also equal to, I mean, it's also a pointer to a character, right?
Yes,
I mean, the array itself is a pointer to, I mean, that is only the address of the first element of the array.
Yes, ma'am.
So exactly the same way, names of I is a pointer to some first element of the array. The same way you have done it here, and therefore you don't need star. If you do star, you are printing the first character of that.
Okay, ma'am.
Is that clear?
Got it, ma'am. Yes, ma'am.
Yeah.
Thank you.
Yeah, it takes a little bit of time to get used to this, but eventually when you get when you get used to it, these things will become clear, more and more clear. Yeah. So I don't know what has gone wrong here. Okay, so yeah, anyway, I think this is clear. Any other question here? Okay, so let's get back to our slides, and just in case you don't see my slides when I say I get back to the slides, please let me know. Okay, so if we print 2, 3, then we will get H. So I think so, because that is what we had said. 2, 3 is 2 is this, so 0, 1, 2, 3. Yes, if you print out 2, 3, you will get H. Names of 2, 3, you will print out H, but you cannot change names of 2, 3. That is what we showed by saying that these are constant strings. I repeat that it doesn't mean that memory allocated on the heap cannot be modified. Yeah. Okay. So the question that one of you had asked is, what if I want to take these names from the user and then print out them, right? So then the way I will do it is I will not initialize them here. So I have still defined this char star names 3, which is a character array, which is an array of size 3, each of which element is a pointer to a character, and then I'm going to scan these strings. However, as we have seen in this visualization also, by saying this and without having this initialization, we just have these pointers. We do not have space for storing these names. So unless we have space for storing these names, there is no point in I mean, this statement, that is scanf percentage names of I, this is correct syntactically because it has correctly the address of a character. I mean, it has the pointer to a character, it has a pointer to the first element of that, but there is no space given, or we have not initialized that pointer. Therefore, if you run this program, you are most likely going to get a core dump. So this program is incorrect because you have not allocated space for storing these names, right? So let us try to correct this and have a space for this name. So let me do the following. That is, I have this char names which has been defined. I have char temp, which is a character array of size 100. I'm assuming that the largest element that I'll get will be of size 99. Therefore, I can have a termination with /0. And then what I do is I scan in this temp, which is perfectly fine because I am scanning in something for which I have allocated memory. And then every time I say, in each of these iterations, I say names of I is equal to temp. Now, first of all, is this statement syntactically correct? Are these Are these okay in terms of the syntax? Can I say names of I is equal to temp? Okay,
No,
so
ma'am.
there are, okay. Let's see if answers from many people I have seen. Okay.
Sorry, ma'am. Sorry, ma'am. I didn't say that. Sorry.
Okay. So there are answers which people are giving, which is good. Please give your answers. So the question is this statement, the highlighted statement, is it syntactically correct? Okay, so there are answers about yes, no. Okay, so please note that names is not a character array. Names is an array of size 3. It is an array which contains 3 pointers to characters, right? So it can hold the address of a character. It can hold the address of any character array, which if it happens to be a character array, which is a null terminated string, then we will appropriately print it when you use printf %s. So all those people who are saying that this is syntactically incorrect, the first thing is we are not trying to copy the the character array contents into names of I, because first of all, names itself is not a character array. Names is an array of size 3. It is a array of 3 pointers, right? So we are not trying to copy. So that is not the mistake here. Secondly, some of you are saying that, yeah, so string copy is certainly not needed because that is not at all even the goal of this. So let me try to use my annotation skills and show it to you again. Okay, so this is maybe it is easier for me to go to this place where I can show you. Okay, so let me try here. So there is this this array of size 3, which is these 3 pointers which have not been initialized. So that is why I'm putting these pointers like this. There is a temp which we have nicely initialized. Temp is here and it is a 100 sized character array with, whenever you initialize it, it is going, whenever you are using a scanf, you are going to initialize these content with a possibly /0 properly terminated string. What we want to do is not to copy the contents here because there is no space to copy something which is of 100 size, but we want to set this pointer to point to temp. This is what names of I is equal to temp is attempting to do, and in fact it does it correctly. So there is no syntax error as far as this statement is concerned. But what is that program doing? It was having 3 pointers. Each time it is taking into this temp some string. Let's say the first time it took sai. So this temp was initialized as sai/0. The first pointer was initialized to this. The second time the same memory location was used to initialize Narsimhan. So then this pointer also went to this location only. The third time you may be initializing it with Vishnu. And so if you print out the elements at the end of it, you will see that all the elements are pointing to the last name or will contain the last name because you have overwritten that memory. So I go back to this slide. If you do this program, if you execute this program, then the program does not have any syntax error. This statement is perfectly fine syntactically. And when you try to print names of I in this place, it will correctly print out names of I to be the right name that you have taken at that point. But after this loop has executed, if you go and try to print out, then all the names will print to the, all these strings will be pointing to the last string, and that is why you will just have that one string that is the last string that you have entered, which will be printed out by this program. So this is how this is why this program is still incorrect, because it is taking one single memory location, making all the pointers point to it, and that single memory location contains the string that you have entered in the third iteration when I is equal to 2. Okay, so I will quickly read through this till the time you assimilate whatever I have said. Okay, so people who are saying that temp is a string and we cannot equate strings, as I said, the goal is not to copy the elements. The goal is to set the pointers. So it is indeed a correct statement. So if there are still some questions, please go ahead and ask me. It will store only the first character of temp. That is not correct, because again, it is setting the pointers. It is not trying to take character by character and look at the elements in that array temp. Okay, any other question? Okay, so the question is, could you repeat why the code is incorrect? So I will go back. So I hope everybody sees the code and remembers the code. So I'll go back to the place where I was trying to illustrate why it is incorrect. So I'll just do this on this board. So the names is a character, names is an array of pointers to characters. So these are pointers which are uninitialized. So I have left them dangling. They are not initialized to something. Temp is a valid character array which has size 100. This is an 100 sized character array, and this is temp. So when I go to this statement scanf %s temp, it is going to go to this location, enter, let's say, SAI with a /0, and in the first iteration, it is going to say names of I is equal to temp, the highlighted statement, which will do the following. Names of 0 is going to point to this location. So this, if you print out names of 0, it will nicely print it out for you psi, which is perfectly fine. So this statement is okay. Then the next time you go into the loop, you are again going to scan this, and this is going to get erased. This will get overwritten, and you will write something which is Vishnu, let's say, no, Narsimhan in the second iteration. So we should have, let's say it's Vishnu. So then it will be with /0, and then this pointer will get initialized appropriately. So in the second iteration, when you are printing again names of 1, it is going to correctly print it out Vishnu for you. So the third iteration also goes correctly, and it will print out the correct name, let's say Narsimhan. But after you come out of the loop, when you look at this setup, this is fine. This is how you have set it up. This now contains Narsimhan. Therefore, it will print out Narsimhan 3 times for you, for the last element that you enter. Okay, so I hope this clarifies to you why the program is incorrect. Okay, so can we use a 2-dimensional character array to, yes, we have already said that we can use a 2-dimensional array of size 3 × 11 to store these names. We have also agreed why this is bad, because these names are small. Some names are small, and this storage is wasteful. Yes, so the program, yeah, so therefore we can, while we can do this 3 × 11, we don't want to do this because it's wasteful to do such a thing. Okay, so the current program will print out the last string 3 times. Yes, here. However, inside it will print out the correct strings one by one. Okay, so one question on this finally I'll take. Why are we taking temp and not and of temp? Remember that we already said when we want to do %s, so forget about all these names and so on. Let's say you wanted to scanf into this temp. We have already said that scanf %s temp is correct. This is the same reason why we are saying that names of I is equal to temp is correct, because temp, I mean the name of the array is the address of the first element. This also we have said it multiple times. So I hope that clarifies it. Okay, so I assume that the reason this program is incorrect is clear. So let's try to fix this. So what is our issue? We have 3 pointers, but we do not have place to store the 3 things. And if we took one temporary array, it is not sufficient because the same temporary array is going to get overwritten. So we need some other way to allocate memory, and that is where we are going to use this memory allocator, which is called as malloc. So this malloc is a function which is provided by the standard library of C, which is present in stdlib.h, and it will allocate the desired memory for you. Desired in the sense how many ever bytes you tell it to allocate, and it will return a pointer to that memory. And this memory is going to get allocated on a heap. It is not going to get allocated on the stack. Therefore, this memory is accessible even after this function that is calling allocating this memory has completed its execution. Unlike the local variables which were allocated on the stack, this memory is going to get allocated on the heap. And of course, you can modify this memory. You can write cells of this memory and change them and so on. The earlier example was a constant string which could not be modified. Okay, so this memory allocator is the function which is called as malloc, and the syntax of malloc is as follows. It takes a parameter which is the number of bytes that you want to allocate. Typically, we don't give the number of bytes as a absolute value. We give it as the number of, I mean, in terms of some function which returns the number of bytes. For example, size of int. If you want to allocate space for an integer, then you can say that size of int is the number of bytes that you want, and the return type of this is a pointer, but it doesn't know what kind of memory you have allocated, for what have you allocated the memory. So it returns a void star. That is, it says that you can take this memory, the pointer and typecast it in the way you like it. So it is the caller's responsibility to do the appropriate typecasting. So we know that it is an integer pointer. So remember, this int star ptr is saying that there is a cell for ptr which has been allocated, but ptr is not pointing to anything unless you say ptr is equal to and of x. So when we said ptr is equal to and of x, the allocation for x was done by some other statement which is int x. Instead, you can say that let me allocate some memory which will be not on the stack, but which will be on some other storage which is called as heap. And this can be done by this function which says by this function which is called as malloc, which will return the pointer, and then you can assign this return value to the pointer that you wish to. So this statement is going to say ptr is now pointing to some integer to a memory cell which is going to be interpreted as an integer, the contents of which are going to be interpreted as an integer, and I am now going to store the address of that in that cell ptr. This statement is saying that, and of course malloc is doing the task of allocating that memory on the heap. So this is the function malloc. It as I said, it returns a pointer to the memory allocated, and the return type is void star. So it is our responsibility to typecast it appropriately, which will be done using this typecasting, which is int star in this case, because we want a pointer to an integer. And yeah, so the memory allocated, as I said, is destroyed only when it is explicitly freed by calling the analogous function which is called as free. we'll come to that free later, or when the program terminates. So if you do not say free, you have that memory throughout for you, but it is your duty to have a pointer to that memory. If you do this int star ptr is equal to this, and then you say ptr is equal to and of y, this pointer to that memory is gone, and then you cannot access that memory again. So that you must have a pointer to that memory, which is your responsibility, the caller's responsibility to hold the pointer to that memory. So any questions on this? We will see the execution of this on some examples, but any questions about the malloc itself? Hello, can somebody confirm that you can hear me?
Yes, ma'am.
Yes, ma'am.
Okay, so hello, Kaushal, are you there? Any other student,
Yes,
can you
ma'am.
confirm that you can hear me?
Yes, ma'am. I can
Yes,
hear
ma'am.
you.
Hello, recording I have started. Hello.
Hello, ma'am.
Yeah, okay.
Hello.
Yeah, I'm very sorry, but the whole campus is facing these issues, so it's not specific to me. Okay, so did everybody, I mean, was I audible when I was talking about this malloc, and was this slide completely described to you? I mean, I did describe it, but
Yes, ma'am.
okay, sure. Okay, so what I'm going to do is I'm going to use this malloc to now try to write this program correctly. Okay, so okay, so I'm going to use this malloc for writing this program correctly. We are having again the temporary array which is of size 100. We still scan each of our strings into the temporary array, but now to make sure that we have memory for storing our different strings, we are going to now malloc as much as memory that is required. And how much memory do we require? We require how much ever is the length of each of these strings plus 1 to store the /0, that is the termination for the string. And then whatever memory we get, we want it as a, I mean, as a character array. Therefore, we are going to typecast it as a char star instead of the earlier example where we typecasted it as an int star. And then we are going to say names of I is equal to char star of this. So by this statement, I have just allocated memory. This memory cell is, these cells are not initialized. So I still need to copy the name into the appropriate place. And this statement, which is strcpy, which is the string copy, which is given to us by the string.h, is going to copy this names into this destination. Whatever is present in the source, that is whatever is the array temp, that is going to be copied into names of I. So this is how you are going to copy it. And now you have three different names stored in appropriate memory cells. This memory is stored in the heap rather than on the stack, and this will be available even when even when it goes out of scope, as long as you have the pointer to that memory location. So this is a correct way to write this program. This is not storing it into a two-dimensional array of 3x11, but simply doing allocating as much memory as is required. And therefore, now when you do a printf %s/n names, then it is going to correctly print out the three names because these three pointers have been correctly initialized. Okay, so I think there is still some question. Here after malloc, names of I is equal to temp won't work. So if you do names of I is equal to temp, you are doing the same thing. That malloc is, you are losing that space. So the question is that after this statement, malloc statement, can I do names of I is equal to temp? If you do that, you are reverting back to the original program. There is nothing that you are doing. Okay, so Kaushal, you are saying something?
No, ma'am, I accidentally muted myself.
Okay, sure. Okay, so how can we now copy temp into names of I? See, names of I is a pointer to the memory, the memory that you have allocated, which is a character array. Which is the appropriate sized character array, and you have the address of the first location. So it is just like you are copying from source to destination. The same way this statement is working to copy something from temp to this names of I. Is that clear, Satyajit? Okay. Okay. Any other questions on this this program? Okay. No, there is no new operator in C. That is in C++.
So we don't need to delete pointers, no, ma'am. Like in general, in C++.
Okay, no, we need to delete the memory that we have allocated on the heap also, that whatever we have allocated. In this program, we are not freeing up the memory, but in general, when you are allocating some memory and it is no longer useful, you should free up that memory. But we are not freeing it here. Just let me complete, because anyway this is in the main program. As soon as the main program goes out of scope, all the memory that is allocated is going to go away. Yes, go ahead, ask your question.
So syntax will just be delete pointer, delete and then the name of
no it will be free. There is a free command, not okay, so let me recall. Yeah, I'm just getting confused whether it is delete or free. I'll look up and tell you. Yeah.
Okay, ma'am.
Okay. Yeah, so is stdlib for malloc? Yes, stdlib is to make sure that malloc is available to the program. Yes. Okay, so I think I have written this here, use of malloc and also stdlib.h. Okay, so I think somebody is asking, can you please explain the malloc slide once again? So yes, but what part is not clear, please tell me so that I can focus on that part. Vijay, you have asked this question, so could you please tell me what part is not clear about this slide so that I can focus on that? Okay, the syntax part. Okay, so the syntax of malloc is the following, that it takes a parameter which is the number of bytes that you want to allocate. So you can say here 10 bytes, that is okay, perfectly fine. But many times we are not going to say explicitly an absolute number. That is why the way we are going to say is whatever is the number of bytes that we want is typically determined by the size of the particular data type. So if you want an integer array of size 10, you are going to say 10 into the size of int. If you want a character array of size 100, you are going to say 100 into the size of a char. if you want a two-dimensional array, you are going to make the appropriate calculations and then multiply it by the size of that data type for which the two-dimensional array is. Once you have that correct bytes, it is going to allocate a contiguous you are going to typecast it appropriately into int star. So that is the syntax of this thing. And as we see in the next slide, when we wanted memory for storing the this string, we are taking appropriate memory in terms of bytes. So this strlen is giving us the length of this string plus 1 for the /0. That is telling us the number of bytes. And then since it's a character array, we are typecasting it as char star. So as we go along and we keep using Malloc, we will be more familiar with the syntax and the meaning of this or the typical use of Malloc. So it's okay if for the first time it seems a little non-trivial, but that's okay. Any other questions?
Ma'am, we are not able to hear you.